Okay, welcome everybody. It is day number 2, and we are in chapter number 2. I hope everything went okay with the first day. If you're having trouble, just send me an email. Let me know what's going on. But remember, reading the emails carefully and checking Inquire, following directions on the video, that's going to be really important for success in this class. So it's an online class, you're watching videos, you're doing homework online, but I want you to treat this like a normal class. Remember, you need to be taking notes. You need to be setting aside time each day. It's going to take a lot of time. We're going to have multiple videos, multiple assignments. There's going to be a lot to do every day. And I think that's good in the sense that we're going to get through this material by going through a series of checklists, watching videos, doing homework assignments. And then building towards a test on Thursday. It's going to be through web work. It's going to be similar to the homework, except the difference is it's going to be timed. It's only going to be an hour long, so you need to have your notes ready, prepared, and you need to study for it like you would a regular closed note test. Okay, so let's get started on the material today. We're going to start with chapter 2, and I like this chapter. I've got some good examples. Let's go ahead and get started. Okay. So let's bring this up here. Chapter 2, let me get to a full screen. All right, chapter 2, describing distributions with numbers. So yesterday what we did was we described data using graphs. We made histograms, bar plots, pie charts, and we were trying to get a sense of the information contained in the data graphically. Today we want to do it with numbers. So a research question we could ask is, how does LeBron compare to Dwight Howard? Let's consider points first. So what I did was I went to basketballreference.com and I got all of LeBron James and Dwight Howard's games for the 2016-17 season. Now I've summarized all of that information. So each of them played 74 games. So there were N equals, whoops, that's not a good 74 games. Okay, so we want to take the information from each of the games, and let me just get out of here and show you this. I've got the information in Minitab over here, and you can see all of this data. Here are the number of field goals, three-pointers, everything. But I'm considering points. And I want to summarize them using numbers. So let's go back here to the summary. And let's take a look at the average points per game for each of these two players. Now this information is the sample mean. This is going to be denoted X bar. On average, LeBron scored 26.4 points a game, and Dwight Howard scored 13.5 points a game. This is going to be a great way to measure the average points per game. All right, now let's look at this, median points per game. All right, this is another way to measure the center, and I'm going to tell you about that in a little bit. But this is going to be the median. Other critical piece of information that we're going to consider today is standard deviation. This is going to give us a sense of, on average, how far did the players deviate from the mean. I will show you detailed calculations coming up, but for now, you're just thinking about this as deviation from the mean. And we are going to label this lowercase s. Now, the final piece of information here is this, the minimum, first quartile, median, third quartile, and maximum. Together, this is a 5-number summary. Okay? So that is a pretty thorough numerical description of the points LeBron and Dwight Howard scored. So what I want to go through now is how to calculate all these things and interpret them. Let's do it. Okay, this is kind of like what I just did. You'll find these at the end of the chapter, and they are summaries. I thought that this would be a nice way to get a sense of what is going on in the chapter. So some keys to be thinking about. We want to measure the center and spread of data. The center, we're thinking about X bar, the mean and the median. The spread, we're going to be using that 5-number summary. And S. That's a 5, and that's an S for sample standard deviation. Okay. We'll talk about the differences between the mean and the median. You see here, we're going to figure out how to interpret the first and third quartile in the 5-number summary. We'll learn how to make a box plot, which is another graph of basically a 5-number summary. Those are pretty straightforward. We need to think about standard deviation and variance, how they're calculated and the information they tell. Remember, that's about spread. We're going to be thinking about a resistance measure and why the median is resistant and the mean is not. Okay, so you can go over this entire summary before you do the chapter or after, but it's a great way to say, what are the important points? How do they tie together? And it's just put together in a really nice, concise manner. Okay, so let's talk about measuring the center. All right, measuring the center. Okay, we've got two methods, the mean and the median. They're both pretty straightforward to calculate, and if you hadn't seen this, I would be surprised. So let's calculate them for a data set. This is going to be the defensive rebound LeBron had through the first 5 games. So N is going to be 5. So in the first game of the season, he had 8 defensive rebounds. In the second game, he had 6. He had 5 in the third, 10 in the fourth, and 6 in the fifth game. So those are the defensive rebounds. So what we want to do for this sample size of 5, get a sense of the center. For the mean, this is a pretty easy calculation. All you do is add up the 5 numbers and then divide by the total. So let's go ahead and do this. So X bar is equal to 8 plus 6 plus 5 plus 10 plus 6 divided by 5, which is 7. He averaged 7 rebounds a game. We can do that for a sample size of 5 or for the whole season, and we'll do that later. Now let's do another type of measure, and this is going to be the median. Okay, so the median, what you do is arrange the orders, the observations from smallest to largest. So let's do that. 5, 6, 6, 8, and 10. And this is, of course, step number 1. So we note that the number of observations is odd. So the median is the center observation. So that is the center. There are 5. So there are 2 on the left of, I'm sorry. So the median is 6. You see that there are 2 over here, 2 over here. The median is the center number. Okay, now what I want to do now is consider if LeBron had some kind of crazy, well, this is impossible to actually have this number of rebounds, but I want to show you what happens when you add a outline value or a value that is kind of crazy when compared to the rest. So let's say that maybe there was an error in bookkeeping. And here were the number of rebounds through, not n equals 5 games, but n equals 6 games. What I want to do is get a sense of how that would change the mean and the median. Okay, so the mean for this is going to be the same, except so we're going to add all 6 of these numbers up, and when you do, you get 120, and you divide it by the total number of observations, 6. When you do this, the mean would be 20 rebounds a game. Notice how this single observation of 85 really made that mean bigger. But now let's calculate the median. All right, so I'm going to arrange the numbers from smallest to largest. 5, 6, 6, 8, 10, 85. Now this time, since we have an even number, the median is midway between the two center observations. So these are the two center observations, and the median is 6 plus 8 over 2, which is 7. All right, I'm going to write that beside the mean up here. The median is 7. And that is kind of incredible to me. Do you see this statement right here? So, whoops. When we added this really big data point, 85, to our sample, the median barely changed. We say that it is resistant to this outline observation. However, the mean really got bigger. It went up to 20. So the mean is not resistant to outline values. What I'm hoping right now is that you have a sense of how to calculate the center of an observation, the mean and the median. Okay, perfect. Let's go on to the next page. This is a very interesting concept. Let's go back to blue. The mean and median of a roughly symmetric distribution are close together. If the distribution is exactly symmetric, then they're exactly the same. If a distribution is skewed, the mean is farther out towards the long tail. So let's do an example of that. Let's think about the CEO example. Oops. Let's look at the CEO example. Okay, so one was age. Okay. Now, the histogram was, remember, it was kind of symmetric? For that example, the mean was 56.2 and the median was 55. Notice that these are very similar because it is symmetric. Now, do you remember the example with pay? This distribution was strongly skewed to the right. Do you remember this guy? This was the Yahoo and Citigroup CEOs. They were outliers. And I just want to notice that this is skewed right. So in this example, the mean pay was $11.7 million a year, while the median pay was $5.5 million. Notice that these are very, very different. The mean is twice as big as the median. And that's because this outlying value here, it grabs the mean and pulls it towards itself. So when it's skewed right, mean greater than median. All right, so skewed right implies mean greater than median. I think that you can imagine what it would be if it was skewed to the left. The mean would be less than the median. All right. Let's go on to our next topic. Yes, the quartiles. Now, this is going to tell us right here how to calculate the first and third quartile. So here we are. right here. This is going to be part of the 5-number summary. And for LeBron James and Dwight Howard, we have the first and third quartile. So let me give you a sense of, first of all, how to calculate them. So again, you arrange the numbers from smallest to largest. Now, the first quartile is the median of the observations left of the median. Oh, Lord, that's a mouthful. And what it does is it tells you a number that about 25% of the observations are less than. The third quartile is the median of the observations to the right of the median. And it tells you a number that about 75% of the numbers are less than. Okay, so let me just do a quick example and then I'll revisit LeBron. Example. So I'm going to have an ordered data set of 1, 1, 2, 3, 10, 12, 20, 30, and 100. That's a nice simple data set. Let's go ahead and find the 5-number summary for this. All right, now this is a very trivial and kind of simple example, but I just want to do it to give you a sense of how to do it. Okay. So the numbers are ordered, so I don't need to order them in increasing order. So the first thing I need to do is find the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are n equals 9 observations. Okay, so that means the middle one is going to be the median, the 5th number. So that is going to be 10. Notice there are 4 observations left and 4 observations to its right. So we note the median is 10. Well, the first quartile is the median of the numbers to the left of the median, not including 10. So these numbers right here. Since it is odd, it's going to be the average of 1 and 2. So Q1 is equal to 1 plus 2 over 2, which is 1.5. Okay, so Q3 is going to be the median of the numbers to the right of the median. Now, notice that I am not including the median in this calculation. All right, so Q3 is going to be the median of these numbers, which happens to be 20 plus 30 over 2, which is 25. So I have my median, my first quartile, and my third quartile. Let's go ahead and just do the actual 5-number summary for this. The final 2 values of my 5-number summary are going to be the minimum, which is 1, and the maximum, which is going to be 100. Okay, so that's how you actually calculate it. So what I want to do now is I want to think a little bit more about LeBron James' 5-number summary. So let me get a new page in here. Oops. Page. I want to append a page on this. There we go. Okay, so let's look at James. Let's look at his 5-number summary. Okay, so I can't remember it, so I'm going to have to go back. Whoops. I can do this. So page up. Okay, so his 5-number summary is 2. Oh, whoops. 16, 21, 26, 31, and 44. I'm getting that right here. Okay, so let me write this down. All right, so min is 16. That's incredible. The fewest number of points he scored in a game was 16. Q1 is, that's strange, 21.75. His median is 26. Third quartile is 31. And the max was 44. So let's interpret that. All right. So first, let's note 25% of games LeBron scored less than 21.75 points. That's what the first quartile tells you. So between the first quartile and third quartile, that's going to be 50% of his games. All right, so note that. About 50 oops, that's not a good 5. About 50% between 21.75 and 31. So what I hope you're seeing is there's about 25% of the data between the min and Q1, 25% between, well, 25% between the median and Q3. And between any two consecutive numbers, there's about 25% of the data. Now that's approximately. It's called a 5-number summary in the quartiles because it splits the data into about 4 parts. So about 25% of the games LeBron scored between 31 and 44. All right, so 5-number summary is great because it gives you a sense of the spread of the data and the shape of the data. Let's look at some of these. A 5-number summary, a really nice thing you can do with it is turn it into a visualization, a box plot. Now I made these using Minitab, and what we're considering here is the field goal percentage that LeBron had and Dwight Howard had. Now this box plot is really easy to make. It consists of 5 parts. It is the min. This corresponds to Q1, this line, the median, this line, Q3, and that's going to be the max. So it's just a visualization of a 5-number summary, and the same goes for Dwight Howard. So you can see that for once it looks like Howard was a little better at LeBron than something, but that's because he plays so close to the basket and is dunking so much. Let's look at some other 5-number summaries and box plots I made. Here's one of assists. You can see LeBron on average is scoring a lot more assists than Dwight Howard. You can see the 5 components of his 5-number summary, and box plots are just a great way to compare two individuals. There's LeBron looking at his points per game versus Dwight Howard. He clearly scored more. Quick note, let me copy this and bring it over to our notes. There we go. So here's a box plot of points. Now, one thing that I want you to think about is this is kind of an outline value. What that means is it's pretty extreme in relationship to the other. It's calculated using something called an interquartile range. Now, the interquartile range is equal to the third quartile minus the first quartile. And if you have a value that is really far outside of that interquartile range, it could be considered an outlier. We're not going to be talking about how to make those in this course, but if you see it, just know that these stars represent pretty extreme gains. So interquartile range, third quartile minus first quartile, and anything that is really, really far outside of there is going to be considered a outlying value, one that was extreme. You can see it was very unusual for Dwight to score 30 points in a game. He only did that a single time. So box plots are a great way to compare two pieces of quantitative data. All we do is use them to visualize a 5-number summary. So let's see what's next. Standard deviation. I love this topic. Standard deviation. Let me give you an approximate definition before you look at this technical math. So this is going to be an approximate definition. On average, how far data are from the mean. So it's trying to measure how far the observations are from the mean, the spread from the mean. I'm going to give you some examples to show you what high standard deviation would look like and what low standard deviation would look like. But before I do that, let me tell you what our magic number is for the day. We're going to have these from time to time in the videos. This is just going to be kind of a homework freebie, but you'll see a question on the homework and it says, well, what is today's special or magic number? The answer is 37. So today's special number is 37. Write that down so you can access it later. Okay, so standard deviation, that is what I'm interested in. Here is the formula. So let's consider what standard deviation measures and just do a couple examples. All right, let me move down here. Whoops. Okay, so let's consider two basketball players and how many points they scored. All right, so here are going to be the points. So this represents points. And this is going to be player number 1 up here, player number 2 up here. And here is 5. Here is 25. Okay. So let's say they both averaged 15 points. 15 points per game. Okay. Now, first let me show you what player 1, what his game was like. He had a 5-point game. He had a 7, a 9, 11, 13, a 15. You see that he scored evenly. Each one of these represents him scoring. So you can see in this game he scored 5 points, 7 points, 9 points. His average points per game was 15. Now let's consider another purple. He had one 5-point game and one 25-point game, but the rest of his games were really close to 15. Okay? Almost all of his games were right at 15. So they played the same number of games. Each of them had a low score of 5 and a high score of 25 and an average of 15. What we want to think about is who had a larger standard deviation. So this represents the mean. X bar equals 15 again. Now remember what standard deviation measures. It says on average, how far are the data from the mean? So what I hope you're seeing is that this player was very close to the mean on average. He had 2 games that were far away, but on average, his values were very close to the mean. Whereas player number 2, his points were on average farther from the mean. So what this says is standard deviation for player 1 was larger. Okay. Standard deviation for player 1 was larger. On average, the data are farther from the mean. Now, what we're not going to do in this class is spend a lot of time calculating standard deviation by hand. It's just not worth it. The computer programs are going to do it for us very, very, very quickly. This is the formula. It is a mathematical formula. And what it says is it takes each observation here and it subtracts it from the mean, squares it, and then averages it in some sense. So let's go down. Oops. And think about how we would calculate it for a very simple example. Were 1, 3, 5, 7, and 9. Let's think about standard deviation. Well, I'm going to note that the mean is 5. Oh, whoops. That there are 5 observations and that the mean is also 5, simply a coincidence. Let's think about standard deviation. So standard deviation, what we're going to do is we're going to take each observation, we're going to subtract it from the mean, square it, plus, let's do 3 minus 5 squared. The next one is 5 minus 5 squared. 7 minus 5 squared. 9 minus 5 squared. Okay, so we are measuring, notice 1 is going to be 4 units from the mean. 3 is 2 units from the mean. We divide by the total number of observations minus 1, and we take the square root of all of that. Okay, so this is just equal to 16 plus 4 plus 0 plus 4 plus 16 divided by 4, square root of that, which is equal to the square root of 10, which is about a little bit over 3. So the standard deviation here is about 3. Now, we don't want to do that calculation all the time, but what I'm hoping you're seeing is that it's not a horrible calculation. All you're doing is looking at the average distance the data are from the mean. Now, the reason we do the squaring there and the square roots is we want the distance the data are from the mean to always be positive. So when we square it, even though 3 is less than 5, when you square it, it still gets that positive deviation. Okay, so let's think just a little bit more about standard deviation before we go on. I'm going to draw you 2 histograms. Let's see here. And these are actually going to be, you can imagine a histogram under here, but I'm just going to kind of approximately draw them. All right, let's do this. So let's say that both of these, the mean is 10. Okay. And let's put this at 2, let's put this at 18, and similar things going over here. So what we can see is that they take on the same types of values, their mean is the same, but which one has a larger standard deviation? All right, I want you to think about that for a second. Let's label this 1 and this 2. All right. Well, the sample standard deviation for this first data set is going to be larger than the sample standard deviation for the second. The reason is it's varying more from the mean. Notice over here, there are very few observations this far from the mean. as opposed to this one, a lot of observations are this far from the mean. So we see there is more deviation from the mean in this first set than this second set. All right. I hope you have got a sense of describing data numerically. And let me tell you one more thing, just a real easy thing. I just want to make one final note. The mode is the most frequent observation. So the mode of this data set, 1, 2, 2, 3, 100, is equal to 2 because it occurred the most number of times. All right, let's go back up to where we started. Let's go all the way to the top. And we were talking about LeBron and Dwight Howard scoring. So you see this numerical summary. So now I hope you have a better sense of all of it. N is the number of observation. Here is our sample mean, X bar. We have standard deviation, which we said was S, and that says on average how far the data were from the mean. The average distance LeBron's games were from his mean of 26 was 6. Okay. We now have this 5-number summary that we understand. It tells us the minimum, the first quartile, the median, third quartile, and maximum. And that splits the data into about 4 equal parts. So roughly 25% of the 74 games he played, he scored between each of these two consecutive numbers. We use these 5-number summaries to make box plots. And I think that's it for today. Good luck on quiz 2, and we'll be back for lecture number 3 shortly.